In this video, we will look at a very similar factoring experience. We're going to factor ax squared plus bx plus c. And the only difference between this and my last video is to notice that we're going to have a multiplier up front, a leading coefficient. Let's take a look at two examples to give us an idea about that. So our first example, example number one, will be, let's see, 6x squared plus x minus 2. And what we want to do is we're being asked to factor that. We're being asked to turn that into, in this case, two binomials. All right, we're going to use the same technique. We're going to focus on the first and the last term, remembering that our middle term is a check term. It's going to be a little more complex this time because we have that leading coefficient of 6. Okay, so let's take a look at the possibilities. How could I possibly get 6x squared? Now, the issue here is there's more than one way to do that. I know that x times x will give me x squared, but how am I going to get that 6? So the possibilities are, well, I could do 3x times 2x. That would give me 6x squared. But don't forget, another possibility is 6x times 1x, or 6x times x would give me 6x squared. And the reality is both of those could work in some situations, not in this situation. But most of the time, only one of those will work. So you can pick one, and if it doesn't work, you can try the other one. So this time, I'm going to start off with a positive. I'm going to try to pick what I think is the right one. I believe that 3x times 2x will work. So let me choose that. I'll use 3x times 2x. Now I'm certain that the first two terms will multiply to 6x squared. Let's take a look at the last term. It's negative 2. And the factors of negative 2, there's not really that many options, right? There's only a couple ways to get that. You can either do negative 1 times 2, or you could do 1 times negative 2. Those are the only two options. And so I realized that there's two options there, but there's also two different things that can happen when I put each one of these into the polynomial. So let's see if I can just purposefully maybe not get this one right. I'm going to try the first set, negative 1 and 2, but I don't know where to put the negative 1 and the positive 2. So maybe I'll just guess. Maybe I'll try putting the negative 1 here and up at the positive 2 there. Then we're going to do this checking technique. And the way we do that is we check our distribution. We only really need to check 3x times negative 1, that's negative 3x, and 2 times 2x, that's 4x. The only reason we need to check that is we're just checking for x. Well, it turns out I didn't do it wrong on, even when I tried to mess up, I still got it right on accident here. Don't worry, I'll do better on the next one. And here's how you know what is negative 3x plus 4x. It's in fact 1x, and that checks out. We needed 1x. So that actually is our factored form. I made that look kind of easy, but it's not always going to be so easy. Let's take a look at, in other words, what I mean by easy is, you won't always get it right on the first guess. Let's take a look at a second example. Maybe I won't be quite as lucky on this one. So let's see. Let's factor the expression. I'll put a line here. 15x squared plus 29x minus 14. Again, I'm going to try and factor it into two binomials. Looking at my first term, 15x squared, I don't know whether it's 15x times x, or is it possible? Probably it is possible. It could be the other way to get 15 would be, let's see, 5x times 3x. How do I know which one of those? Maybe I don't know. And furthermore, when I look at the last factor, negative 14, I don't know how to get that. It could be negative 1 times 14, or positive 1 and negative 14, right? It could be the sign change there, 1 times negative 14, or I might have negative 2 times 7, or 2 times negative 7. There's 4 options there. So it's really pretty overloaded. So here's how you might go through it. I'm going to guess purposefully wrong here. So maybe I just don't know. I'm going to try this first one, 15x and x. And then which one of these number sets do I use for 14? I don't know. I'll just grab the first one. I'll try negative 1 and positive 14. Well, as soon as I start multiplying, I notice my numbers get pretty large. 15 times 14. I need a calculator for that. It's 210, I believe. Wow, that's too big. Minus x, 209x. That's way too large. Remember, my check term is 29x. So I know that's not right. So then I say, oh, well, let's see. That just means that I can't use the 1 and the 14. And by the way, the negative 1, the positive 1 and the negative 14 won't work either, because just switching to the other signs will only change the sign and not the number. So that shouldn't work. So let's try the negative 2 and 7. Let's try the negative 2 and positive 7. And here I get 15 times 7. That's 105. Take away 2. That's 103. That's still way too much. That's way past my 29. So at this point, I've tried the negative 2 and 7 and the 1 and 14, and none of it worked. So I'm going to conclude that probably this doesn't work at all. In other words, 15 and 1 doesn't work. So I'll try my second one, 5x and 3x. Again, you would guess numbers, the 1 and 14 and the 2 and the 7. I'm going to go with, let's see, let's put the 2 here and the 7 here. I'm going to show you something that I didn't do it on the previous one because I was wanting to make the video as fast as possible. I want to show you something that can happen. If you do a check here, 5x times 7 is 35x. That's a lot more reasonable. And then 2 times 3. Okay, I'm just noticing, guys, that I didn't put the right sign on that. I need one of those to be negative. Let's put this one to be negative, all right? Then negative 2 times 3x will be negative 6x. I get 35x minus 6x. Voila, 29x, exactly what I want. But I want to show you something. If you had accidentally guessed the 7 here and the negative 2 over here, in other words, if you put it in that direction, watch what would happen. You get 5 times negative 2 is negative 10x, and 21x, and you would get 11x. That wouldn't work. So not only are the numbers important, when you have a leading coefficient, the position is important. It has to be something that you check. You want to make sure you get that 29x. So the one that did that is this particular one that you see me highlighting. 5x minus 2 times 3x plus 7 is the correct answer, and you conclude that the other ones are not correct. I hope that gives you a little bit about this kind of